Welcome guys to my channel. Today we're going to learn about aromaticity, non-aromaticity and anti-aromaticity. And the point of this video is for you to make it easy for you to understand and to differentiate among the three. So the first thing you have to know is that this is the benzene ring. And so that's the most famous aromatic compound. And so sometimes it's drawn like this because the resonance, the continuous overlap of pi orbitals are that are shown as a circle. Reactivity and stability. Now, the benzene ring is very stable, and we can see it here because the alkene gets brominated pretty easily, but no reaction happens with the benzene ring. Okay, so you can see that the reaction is not favorable because it will break the stability, the special stability of the benzene ring given to it by the continuous overlap of pi orbitals. Now, the criteria for aromaticity is not restricted only to six-member rings. These compounds are all aromatic because they form a continuous overlap of the pi orbitals. If you notice, we have here one lone pair, right? So those pi bonds are conjugated, those electrons are going to be conjugated, and equally here is going to form resonance structure, remember? And then the third compound is also conjugated and it's planar, so it's going to be aromatic. So the criteria for aromaticity, this is the most important part. There must be a ring comprised of continuously overlapping pi orbitals. So we can see here that this guy is not aromatic because there is an sp3 carbon that interrupts the continuous overlap of pi orbitals. And obviously this is not aromatic because it's not cyclic, even though the pi bonds, its bonds are conjugated. And then the second criteria is that the ring must contain an odd pair of electrons. This guy here does not contain an odd pair of electrons. This guy here, which is the benzene ring, it does contain an odd pair of electrons, right? In total 6 for a total of 3 pairs of pi electrons, right? And then the third compound, it is not aromatic. Also, is not aromatic because it contains an even number of um, pi electrons. So even numbers of pi of pairs of pi electrons. Okay, so only the compound in the middle is aromatic. Now the Huckel rules. Um, Huckel's numbers are 2, 6, 10, 14, 18, etc. And they are summarized by 4n plus 2, where n is a series of integers 1, 2, 3, etc. So we can see here that these are the guys before, and we are now analyzing them in terms of the Huckel's rules. So Huckel's rule says that in order for a compound to be aromatic, it must have 2, 6, 10, 14, or 18 pi electrons, which if you have that, you're going to get an odd number of pairs of electrons, right? 1, 3, 5, 7, right? 9, right? If you have those numbers, right? So we can see here why the first compound does not meet Huckel's rule, right? It has an even number of pairs of electrons. And then the second compound, the benzene ring, it does actually meet Huckel's rule, the benzene ring, right? Because it has an all numbers of pairs of electrons. Okay. And then the third compound also does not meet Huckel's rule, so it is not aromatic. Anti-aromaticity and non-aromaticity. So in order for a compound to be anti-aromatic, it must satisfy the first criteria but fail the second one. Okay, right. So this guy here, it forms a continuous overlap of pi electrons, but has an even number of pi electrons, which fail the second criteria. Okay. This means that this compound is actually anti-aromatic because it is also planar. If you see it from this direction, from the sides, you're going to see that it is planar, and it is conjugate, right? It forms a continuous overlap of pi electrons, but it fails Huckel's rule. It has an even number of pairs of electrons, of pairs of pi electrons, right? So it is anti-aromatic rather than non-aromatic. Now, pay attention to this. I'm sorry. Let's see. Let's see. For a compound to be non-aromatic, it must fail both criteria, and this compound fails both. Now you might be thinking, wait a minute, that looks planar to me. No, it is actually not. So first of all, it is conjugated. Okay, great. But that conjugation gets interrupted because this guy puckers out like this. As you can see, it is not planar. So that actually interrupts the conjugation. So it doesn't fully meet the requirement. So it fails it. And it also fails, as we saw before, it also fails that the ring must contain an odd pair of electrons for it to be aromatic. And the pairs here are even, right? One, two, three, four pairs of pi electrons. So it fails both. So that's non-aromatic, and it is not planar, non-aromatic. And this one here is anti-aromatic. It is planar. It has conjugated electrons, but it fails Huckel's rule. And so here is a summary of how to differentiate among the three. If it is aromatic, it is cyclic, it is conjugated, it meets Huckel's rule, and it's planar. And that guy is benzene and countless others. Anti-aromatic. If it is cyclic, if it is conjugated, if it has 4 pi or even pairs of electrons, not 4n plus 2, but oh, my mistake. This is supposed to be 4n, right? Number of electrons. So 4n or even pairs, then it is anti-aromatic. And of course planar, right? Now, if it fails any of the previous criteria, then it is non-aromatic. And that guy is cyclooctatetraene, which is cyclic, but it's not planar, right? It's conjugated. It is conjugated. It has 4n or even pairs of electrons, but it fails that it is not. It fails that it is not planar. I mean that it fails because it is not planar. So I hope this helps. And please, if you like my videos, try to subscribe. And we're going to go over numerous topics in organic chemistry, ranging from mechanisms to how to draw structures and kinetics. Thank you for viewing this video. Please hit that subscribe button.